Particle filter is important in robotics, mainly for its applications in position and state estimation. Many common sensors in robotics like LiDAR and 3D camera can be used to localize the robot with the help of particle filter. The first step is to initialize the particles. If you don't know where the robot is at in the map, just generate particles by uniformly distribute them on the map with equal weights. If you have a good approximation of where your robot starts, use it. For example, if your robot has a charging station or starts at a competition at a certain location in a maze, the uniform distribution will not converge as fast as just initialize the particles around the start location. The second step is to sample the motion model. In your homework or labs, this is probably done by sampling your keyboard. In actual robots, encoder on the wheels or motors and IMUs give the motion on the transform. The motion model is applied to all particles. The third step is to read the measurement model and assign weights to the particles. I like to call it the sensor step. This is the step the program reads the LiDAR or 3D camera or whatever sensor and figure out how different it is from the expectations of the particles. The arrow is used to assign weights of the particles. The smaller arrow, the larger the weight. The weight is then normalized and used to give the final estimation of the position. The weights must all add up to 1. And as a result, the position estimation is just the sum of positions of particles times the corresponding weights. And finally, we have to resample the particles to make the estimation more accurate. Particles that have larger weights are more likely to be resampled than the ones that have smaller weights. So that basically makes it converge. I want to show you guys a real-world application of particle filter. So here is the TurtleBot3. On the top here is the LiDAR. It is a proximity sensor with a motor, which basically rotates to get distance reading from 360 degrees. And below here is the microcontroller with the embedded IMU, and for the wheels we have 2 motors with encoders. TurtleBot3 is commonly used in education and research, and we'll show you a live demo of it. So here we have our TurtleBot. On the top left is a map of my apartment. The green dots are the LiDAR readings, and the small arrows are the particles. Now let me set the initial guess since I know where my robot is at. You can see the particles are now generated around the robot instead of randomly scattered. Now I make the robot move to another position. You can see the particles start to slowly converge to the actual position of the robot. And now it is almost fully converged due to the sampling. Now if I pick another position, you can see how the particles closely follow the robot. It will not diverge again with accurate sensor readings. The robot's motion update, however, is really bad due to the fact that it is driving on the carpet, the encoder is no longer accurate, and IMU is pretty useless when the robot is wobbling. You can see it does a pretty good job here despite the wobbling, and you can see the LiDAR kind of just matches the map. Now let's try to do something tricky here. If I set the initial guess to some other location, will the particle filter converge? You can see now the particles are again distributed over almost the entire region. If I ask the robot to move due to incorrect initial guess, particles are just scattering groups over the map, and I don't think it will converge. So maybe let's try something else. So if I give it a closer wrong guess here, I can see the particles kind of start to converge around the robot. The LiDAR reading began to match the map, and now it's almost fully converged. Now if I ask it to go to another location, it will just repeat what it did at the beginning. So that's pretty much all I want to talk about particle filter in real life applications. Besides robot arms, mobile robots are also a very big and interesting area to study in robotics. Also for TurtleBot especially, TurtleBot has its own simulator available in ROS. so you can try them out if you don't want to buy a TurtleBot. And thanks for watching.